Welcome to my lecture series. Today I'm going to show the system of equations using Cramer's rule. Let me talk about the rule. Suppose I have a system of equations ax plus by equals c and dx plus ey equals f. First, I'm writing the determinant for the coefficients from left side, a, b, d, e, which is ae minus bd. And then I'm taking another determinant for x. So in this case now the column I have AD for x will be replaced by CF. So you have this one here, and then you get determinant value which is CE minus EF. And finally, for the y variable dy, I'm keeping my first one, and y column will be replaced by CF now, and the determinant value is AF minus DC. And then you get your x equals, you write the determinant for x over determinant for the coefficients, and y will be same way for y, and then d here. And when you plug the values, you get the solution for x and y. So we have cases. If determinant for the coefficients non-zero, so then we call this non-singular matrix for this one, or some non-singular form, you have unique solution. If d equals 0 with the determinant value equals 0 with this determinant is 0 and y also gives you 0, then this system is called dependent and you have infinitely many solutions. And the third case, if your determinant is 0 with determinant for x and determinant for y non-zero, then the system has no solutions and you are done. Let me take an example. I'm writing x plus y equals 2 and x minus y equals 22. So first we see what is our determinant for d. This one will be 1, 1, 1, negative 1. And this gives you negative 1 minus 1, which is negative 2. So we take for dx. So now first column 1, 1 will be replaced by 222, and then take the determinant 2 times negative 1 minus 1 times 22, that gives you negative 24. And then we are taking for y. So my first column is as it is 1, 1, and then y column will be replaced by 2 and 22, and then 1 times 22 here minus 1 times 2 is this. So 22 minus 2 is 20. So you got your d, you got your dx, you got your dy. So you can see now x will be determinant dx over determinant d. Our determinant d is non-zero, so this has unique solution. So the value for dx is negative 24 and d is 0, sorry, negative 2. So then negative 24 over negative 2, that gives you 12. And y equals determinant for dy and determinant d. Like this value, simplify, you got negative 10. So your solution system is, now the solution is given as x, y, which is 12, comma, negative 10. This is our unique solution in this case. Take another example. Suppose you are given x plus y is 2 and 2x plus 2y equals 4. So your determinant for d will be 1, 1, 2, 2. So that gives you 2 minus 2 equals 0. So this system doesn't have unique solution. Now we want to see what kind of solution we have. Is it infinitely many solutions or no solution? So now dx will be 2, 4, because first column will be replaced by this constant column, and then the second one will stay as it is. So this one 2 times 2 is 4 minus 1 times 4 is 4. That is also 0. Now dy will be 1, 2 I have here, and this one will be replaced by 2, 4. So that one is giving now minus 4 minus 4. This is also 0. So we have got d 0, dx 0, dy 0. So this is the second case in Cramer's rule that we have discussed before. Since we have d 0, dx 0, dy also 0, this system has infinitely many solutions. Example 3. I have x plus y equals 2 and 2x plus 2y equals 7. First, see what happens to determinant D. So I have 1, 2, 1, 2. When you simplify, you can see that it is 2 minus 2 equals 0. Now we need to replace our first column by the constant 2, 7 here for x and keep your y column as it is. And then you are getting 4 minus 7, which is negative 3, not equals 0. This one also same way, you keep your first column and you're changing y column with the constant 2, 7. That gives you 7 minus 4, which is 3, not equals 0. So this is our third case where we say that the system doesn't have solution at all. Thank you. Example 4. We have the system of equations, but we have one unknown constant here, k. So we need to write the solution in terms of k. Now, if we want to find the solution of this system, first we find d, which is 1, 1, 3k coming from the coefficients here, xy coefficients. And then you get 1 times k minus 1 times 3 is here. So this is your d determinant. Now, replace your first column, which is 1, 3 here, by 2, 5. And then keep your second column for y as it is. Now you have 2k minus 5, this is your dx. And then the determinant for dy will be same way. You get 5 minus 6, which is negative 1. When you write the solution for this system, you can see your dx determinant is 2k minus 5, put it here. And then the determinant that k minus 3 goes there. So this way you find your x and y in terms of k, you are done. Now, we may ask you another question that when this system does not have unique solution. So then you understand that it does not have unique solution if this determinant value is 0. That means the system doesn't have unique solution. If this determinant d is equal 0, that means k minus 3 equals 0 or k equals 3. So if you write k equals 3, this system does not have unique solution and